What's up guys, this is Massey. Welcome to another video. In this video I want to talk about intersections of lines in 2 space and 3 space. I'm gonna start with the first example. It says classify each system as having 0, 1 or infinitely many solutions. L1 and L2, two different lines, is 4x minus 6y equals to negative 10. And L2 is 6x minus 9y equals to negative 15. As you see here, if I write both of them as 4x minus 6y plus 10 equals to 0, and here 6x minus 9y plus 15 equals to 0. If I multiply this equation by 1.5, I get exactly the same as equation as the second one. It means that the lines are identical and we have infinite number of intersection. That's one method to solve it. Another method, I'm going to use substitution or elimination method. Let's do elimination. We have 4x minus 6y plus 10 equals to 0. 6x minus 9y plus 15 equals to 0. If I multiply this one by 3 and this one by 2, that's going to be 12x minus 18y plus 30 equals to 0. And here 12x minus 18y plus 30 equals to 0. If I subtract them, these two cancel out, and we have negative is going to be 0y because we subtracted. 0y plus 0 equals to 0. So 0y equals to 0. For any y values, that's valid. It means that for any x value is valid as well. So that's another method that you can figure out. We have two identical lines. Let's see next example. It says classify each system as having 0, 1 or infinitely many solutions. So we have two different lines. Both of them are in terms of vector equation. Let's see how to deal with this one. So first of all, here we have the slope negative 6, 8. Here we have 9 and negative 12. So it means that negative 6 and 8. And here we have 9 and negative 12. When you multiply this one by negative 3 over 2 or negative 1.5, we get exactly the same thing. So we have the same direction or same slope. So we have two scenarios here. We have parallel lines, but they are distinct. Or we have identical lines. So we have one of these two scenarios now. Now how can I figure out? If we have identical lines, it means that this point satisfies this equation, or this point satisfies the other equation. So let's check that. If it satisfies, it means that we have two identical lines. If they don't, it means that we have parallel lines and distinct. So we can say 1 equals to 2 plus 9t. And 5 equals to 1 minus 12t. So for the first one we have negative 1 equals to 9t. So t is negative 1 over 9. And here we have 4 equals to negative 12t. t is negative 1 over 3. So two different t's. It means that this point is not satisfied the second line. So we have no intersection. And we have two parallel distinct lines. Let's see in general what are the possibilities. We have 4 different possibilities for intersection of lines. One of them is the lines are distinct and intersect at only one point. So there is exactly one solution. Second case, the lines are coincident and they have infinite number of solutions. It means that we are having two identical lines. Third, the lines are parallel and distinct and there is no solution, like the previous example. And the last one, we have two lines that are distinct but not parallel and they do not intersect. They are called skew lines. Skew lines, they don't have any solution. They are not parallel and they also don't intersect as well. So next example, determine if these lines intersect. If they do, find the coordinates of the line of the point of intersection. So we have two lines in here. As you see here, they have the same direction. They are parallel. So we have two scenarios. Either they are parallel and distinct, or they are identical or coincident. Let's check. If they are coincident or identical line, this point satisfied in this equation or this point is on this line as well. Let's check that. So 5 is going to be equal to 1 plus t. 11 equals to negative 9 plus 5t. And 2 equals to 9 minus 2t. So for the first one, t equals to 4. For the second one, t equals to 4. And for the third one, we have t equals to 7 over 2 or 3.5. Since we have different numbers in here, it means that these two lines doesn't intersect and we have no solution. So we can say lines are parallel and distinct. Now let's see this example. It says find the point of intersection of lines L1 and L2. We have xyz equals to 7, 2, negative 6 plus s times 2, 1, negative 3. L2 is xyz, 3, 9, 13 plus t times 1, 5, and 5. So if I want to write it in terms of parametric form, we have 7 plus 2s, y equals to 2 plus s, and z equals to negative 6 minus 3s. L2 is x equals to 3 plus t, y equals to 9 plus 5t, z equals to 13 plus 5t. So now let's make these two equal, and these two equal. So we have 7 plus 2s equals to 3 plus t. So we have 2s minus t equals to negative 4. That's one equation. The other one, 2 plus s equals to 9 plus 5t. So we have s minus 5t equals to 7. Next one we have negative 6 minus 3s equals to 13 plus 5t. So we have negative 3s minus 5t equals to 19. So now let's solve the equations. This one is gonna be good, so let's have s minus 5t equals to 7. I choose these two. Negative 3s minus 5t equals to 19. If I multiply the second equation by negative 1, so it's gonna be like that, and when I add them, these two cancel out. We have 4s equals to negative 12. S will be negative 3. When you sub it there, sub in here, we have negative 3 minus 5t equals to 7. So negative 5t equals to 10. T equals to negative 2. Now we need to sub it on the first one and see if it's valid or not. So we're going to say 2 times negative 3 minus t, which is negative 2, equals to negative 4. So we have negative 6 plus 2. Yeah, that works. So both of them works and they intersect when s is negative 3 and t is negative 2. When you sub it there, we can find out the point of intersection. So for example, I'm going to have t equals to negative 2. So we have 3, 9, 13 plus negative 2 times 1, 5, and 5. I wrote this one and I subbed negative 2 in here, so that's why I got 3, 9, 13 plus negative 2 times 1, 5, 5 is going to be 1 minus 1, 3. So that's going to be the point of intersection. Now we have another example very similar to the previous one, so we need to do the same procedure. As you see here, we are not dealing with parallel lines, so we have two cases. One of them they intersect at one point, or we are dealing with two skew lines. Let's check that. So they might intersect, or we have two skew lines. So we need to write it in parametric form, each of them. For L1, x equals to 5 plus s, y equals to negative 4 plus 2s, z equals to negative 2 plus 3s. L2 equals to x equals to 2 plus 2t, y equals to 0 minus t, z equals to 1 minus t. So we do the same thing. 5 plus s equals to 2 plus 2t. Negative 4 plus 2s equals to minus t. Negative 2 plus 3s equals to 1 minus t. So we have s minus 2t equals to negative 3. That's the first equation. Here we have 2s plus t equals to 4. That's the second equation. And here we have 3s plus t equals to 3. That's the third. So I'm going to use the second and third because it looks easier. So when you subtract it, you have negative s. 4 minus 3 is going to be 1. So s will be negative 1. So when you sub it there, here or here, to find t, so we have 2 times negative 1 plus t equals to 4. So we have negative 2 plus t equals to 4. So t will be 6. So if I sub these two numbers in the first equation, and if it works and valid, it means that they intersect at one point, and we have the s and t. If this s and t doesn't work in this equation, it means that we are dealing with two skew lines. So let's check that. S is negative 1 minus 2 times 6 has to be equals to negative 3. So we have negative 1 minus 12, negative 13. So negative 13 is not equal to negative 3, so we are dealing with two skew lines. Now in the final example, we need to find out the distance between the skew lines. So L1 is 5, negative 4, negative 2 plus s times 1, 2, 3. This one is x, y, z, 2, 0, 1 plus t times 2, negative 1, and 1. So how do we figure out? We need to use the formula, which is saying that P1, P2 dot normal vector divided by normal vector. So let's find it. First of all, we need to find normal vector. Normal vector is going to be the cross product of these two, which is going to be A and B is going to be A2B3 minus A3B2, A3B1 minus A1B3, A1B2 minus A2B1. So A2 is 2, B3 is 1, A3 is 3, B2 is negative 1, A3 is 3, B1 is 2, A1 is 1, B3 is 1, A1 is 1, B2 is negative 1, A2 is 2, B1 is 2. So we have 2 plus 3, 5, 6 minus 1 is 5, and here we have negative 1 and negative 4 is going to be negative 5. Or we can write it as 1, 1, negative 1 if we reduce it. So that's the normal vector. If I want to find out the magnitude of normal vector for the denominator, is going to be 1 squared plus 1 squared plus negative 1 squared. That's going to be root 3. Now let's find out P1, P2. P1, P2 is going to be this point minus this point. 2 minus 5, negative 3. 0 minus negative 4, positive 4. 1 minus negative 2 is going to be positive 3. So we have, now if we sub it here, we have the dot product of these two. Negative 3 times 1, negative 3. 4 times 1, positive 4. 3 times negative 1, negative 3 divided by root 3. So we have negative 6 plus 4, negative 2 over root 3. And that has to be absolute number because it has to be positive. So when you calculate it, it's going to be 1.15.